Hello, my name is Cameron Buckeye. Today I'm presenting the EE347 lab final. Right before us is the sys tool simulating the open loop uh, system of our motor system. So what we've done is we moved these poles such that we have a percent overshoot that's under 85%, which we have. We have a settling time that's less than 5 seconds, which we have, and we have a final value that's within uh, zero point 0.5 error, so that's between 0.5 and 1.5, which we've met. We're really close to 1, which is really good. So now we're going to move on to the next part of the lab final. All right, so for our PI controller portion of the lab final, what we've done here is we've selected a real 0 point at negative 0.5. And you can see in the lower left corner here are essentially our transfer function that we use to model that. Um, it meets all the lab final requirements. We can see that our percent overshoot is a little high at 83.6%. Our settling time is covered up, but our final value is at 1, which is more than stellar. Let me move this really quickly, and you can see our settling time is 3.88 seconds for this portion of the lab for the PI controller. Okay, for the lead controller portion of this final, we essentially have uh, added another factor here such that we have a real pole at negative 0.7, and we're still maintaining that real zero at negative 0.5. And what we can see here is that our overshoot is 78.2%. Our settling time is 2.29 seconds. And our final value is 1.03, which is, well, all meeting requirements still. Okay, lastly, for our PID controller configuration, we're going to want our real zeros to be really far away from the requirements in yellow in the top right. And if we look at our step response, that does exactly what it's supposed to. It does an amazing job, and our percent overshoot is really small at like 23.3%. Our settling time is at 0.522 seconds. And if you look at our final value, it's right at 1. So it does everything it needs to.